Let's start doing some actual MPI. MPI is a library, so you need a .h file to declare the prototypes of the routines to your program. So in C, you write include MPI.h, and in Fortran you write include MPIF.h or use MPI. There's actually a better mechanism in the Fortran 2008 standard, but that is not widely supported. C++ bindings also don't really exist. They used to exist, but they are deprecated. So for C++, just use the C version of every routine. Now to have some parallel, to use MPI in your code, you need two lines, MPI Init and MPI Finalize. You typically put them all the way at the start and end of your program. So not just in a location where you think things need to become parallel, but just put them all the way around your program. In Fortran, it's also MPI Init and MPI Finalize, but the routines look slightly different. The C routine accepts the command line arguments, or you can actually just specify 0 and 0. And MPI Finalize has no arguments in C. In Fortran, command line arguments are not part of the language standard, so they don't appear, but instead there is an integer parameter that corresponds to an error code that can be returned. So if you look at the C routines, this error code is a function return, whereas in Fortran it's a parameter. So with the exception of routines like MPI Init that are slightly different in C and in Fortran, in general, the Fortran routine will have exactly all the parameters of the C routine plus the error code as a final parameter. So MPI Finalize is a good example. No arguments in C, and one more argument, namely the error code in Fortran. Now about those error codes. Strictly speaking, you could catch them and try to act on them, but it's very hard to recover from errors in parallel, so I usually dispense with it. I will also show Python versions of the MPI routines. Those don't have the error code. They can throw an exception if there is a problem. Okay, so exercise number 2. Take your Hello World program, put MPI Init and MPI Finalize in it, and now have 3 print statements, where one comes before MPI Init, one between Init and Finalize, and a print statement after the Finalize. Run your program in parallel and explain the output that you get. It's of course a good idea to use 3 slightly different print statements.